Good afternoon, everyone. I hope you had a great day, and thank you for coming to the last session. I know it's been a long one for you. You've probably learnt a lot, but probably all desperate for a beer as well, so I appreciate it. I'm Jessica. I've come across from the UK, over in Nottingham. I'm a developer, and today I want to talk to you about dashboards. I guess that's probably obvious from the title, but here we go. So what is a dashboard, and why should you care? Everybody uses dashboards pretty much day to day, even if we don't really think about it. A lot of people use kind of modern banking apps, such as Monzo or Starling, track their expenditures through using graphs, etc., notifications. And then you've got some people who are lucky enough to have like a Google Nest in their home, monitor when their heating's on, maybe adjust it depending on whether they're out of the house or not. My favorite type of dashboard is a good old car dash. Now, this might seem like a strange thing to have a favorite dashboard. I'm just that kind of nerd. But dashboards in cars are particularly interesting to me because no matter if you're a passenger or if you drive yourself or whether you play too many computer games that involve speeding through roads, you can sit down in any car and pretty much recognize what's going on, the information you need, and how to react to it. So let's have a quick look. The first thing you'll spot is the speedometer. This is telling you how fast you're going. And it's normally the big circle right in the middle. The reason for this is because you need to know about this information in real time. If you're going too fast or too slow, you'll be breaking the law. You know how quickly you have to react to this, pretty much immediately. If you're speeding for longer than you should be, which is, not that long, you might get points on your license, or you might get into a crash, or otherwise. You know the consequences. So from this simple dial, you know the environment that you're currently in, you know how you need to change your behavior based on that environment, and you know the consequences if you don't change that behavior. Next, we have kind of warning signs, your indicator lights, your fog lights. Again, you know what it means. Your indicator light's on means your indicator light's on. You know what it means to other drivers on the road or people who are walking by. They think you're going to turn. If you don't react to it within a timely manner, it could be confusing to other drivers. Again, you could cause accidents. It's not as severe as the speedometer. You don't have to react as quickly. But you still know what it means, how to react, and when. And then there's that blooming thing. The thing that tells you that you're going to have to take a day off work, go to a garage, beg your parents for some money, if you're me. The check engine light. Anything red and in that corner is bad news. You're not going to be able to react to it immediately unless you know how to fix your own car. And a lot of us can't these days because electric cars. But you know that you're going to have to go to that garage, spend that money. It's going to be a right pain. Because if you don't, you're going to probably be at the end of the road without a working engine, and it's going to cost you either a new car or a lot of repair. It's going to cost you more money overall. So we've got 3 levels of almost warning here. We know the time in which to react, how to react, and what's going to happen if not. And the most important lesson from the good old car dash, if you cover it with duct tape or just cover it up so you can't see it, the problems are still going to happen. Trust me, I've tried. Putting some tape over your check engine light doesn't make it go away. It'll still cost you £600. And it's the same with any of our dashboards. If you've got a dashboard telling you about the state of your system, hopefully indicating how you should be reacting to it and helping it stay healthy and so that you don't have to go wading through logs too often. If you have that screen off and you aren't looking at them, the problems aren't going to solve themselves. So this is why I think dashboards are important. And more importantly with the car dash is what I was referring to earlier. Anyone can sit down in front of this dashboard and know the information that they need. Why aren't we doing that with our infrastructure and software dashboards? Everybody has a different layout for how they demonstrate this data, how they display it. But if we all kind of had a consistent way of showing this information, we could go to different teams and instantly know the state of play. And that's what I want to talk about today. So before I start, I am going to be talking about metrics in this talk rather than diagnostics. Sorry, I'll be taking quite a few drinks during the session because I've been quite ill today, unfortunately. So I've got quite a dry throat. But I'll be talking about metrics, which are a high-level view of your system. These are the graphs that you tend to have on your screens. They're normally in quite full view of everybody because you need to know what's going on in real time normally. They're kept in present view. They're normally next to your dev teams, your operations teams, and they're for assessing a system and spotting issues. Whereas diagnostics are your logs, kind of your more low-level information. Once you've seen a problem on your metrics, you normally have to dive in and actually find out what's going on, but your metrics will tell you where to look. So they're used more for tracing, debugging, and fixing issues. So let's talk about these suggested baselines. First of all, I would like to talk about services. There's a very smart guy called Brendan Gregg, whose blogs I read a lot of, and I think he's great. He talks a lot about infrastructure, and in particular, USE as one of these baselines. And USE is something that I tend to use for my services when I mostly do back-end development. I'm going to talk through this acronym a little bit. First of all, U stands for utilization. Now, Brendan Gregg uses utilization to talk about the percentage of which something's being used. So how much of your CPU is currently in use, for instance. You could do this with your services. You'd need to do some load testing to find out what your capacity of your service is. It's not always the easiest thing to do. So I actually measure duration for this particular metric rather than utilization. So I've got this little drawing here. Apologies, you'll have to put up with a lot of my doodles throughout this talk. But here we have a guy walking into Big Corp, going in, doing some work, and coming out again. And this is the same sort of thing that I measure for my services, for my duration. My input and how much time it takes to do that work before I get my expected output. If it's slow, I know that something's going wrong. If it's unexpected. If it's about the right speed, then all's good in the world, and I can ignore my dash for a little bit. S stands for saturation, the degree to which work is queued. Brendan and I agree on this one. So in this case, there's a queue of people waiting for the toilet's in use, and that queue is going to keep on getting longer until it's freed up to do more work, for the want of a better word. This might actually be queues in your system. It could be Rabbit, for instance. Maybe that queue's getting longer. You can do this based on how much is in your queue and the age of the oldest message, for example. But in use with combination with utilization or your duration, if your service is getting slower and that queue's getting longer, probably want to be looking inside the service. If the service is working the sort of time that you expect, but that queue's getting longer, something else is going wrong. And finally, we come to E, error, the one that we probably all expect. Does anyone recognize this fellow? Good. I did this talk a while back, mostly to university students. They had no idea who Clippy was, and it made me feel quite old. I actually quite miss him. But error is just what it says on the tin. It could be a 500, for instance, quite a high-level error. Or it could be errors that you've written yourself within your service that give you a bit more detail about what's going on. But with these three things, you can already tell quite a lot about what's happening in your system and where you need to be investigating. Whether it's the information from your errors, the duration of your service, or the saturation of your queues, you know where something isn't working the way you'd expect. And normally with this sort of work, you'd have a baseline so you'd know what normal behavior would be. The thing I work with most, in all honesty, is APIs. Not just APIs as we know and love them. I also work a bit in Lambda and AWS. This is going to be my focus for today. We'll go through 2 different types of baselines, how they relate to each other, and then I'll do a bit of a demo with Grafana as well, and talk about how this has worked for me in production. The first one I want to talk about is the 4 golden signals by Google. This is discussed in their site reliability engineering book. They've got 2 of these out now. The first one is quite light and lovely if you're going on a train journey, because it's carryable. The second one is full of great information and for holding open doors. It's a bit heavier, to be honest. But highly recommend reading both, and both of them contain the 4 golden signals. And these are traffic, error, latency, and saturation. Just to confuse you, saturation means something completely different here. But there we go. So first of all, we have traffic. How much your API is being hit within a certain amount of time. So in this case, how many cars are going through my endpoint within the last 1 minute. This is normally pretty standard from what I can see for measuring with APIs. You want to see how much you're being hit. Often people have a relative idea of how much they can get hit. It's useful in combination with the other 3. We have error again. Error is particularly interesting in this case, in my point of view. So Google proposed that you shouldn't just measure error, but measure it in ratio to successful calls. So error in this case could, again, be your 500s. And your success could be your 200s for HTTP status codes. In this case, you want to see how many of your API calls are successful opposed to erroring. And that ratio should show you whether you're having problems or not. Most APIs will have a few errors. It's the way it is. But not only this, the reason why I find errors particularly interesting with APIs is because they're contextual. Yes, we have our high-level errors, such as 500. You don't want those. But in certain cases, something like a 404 not found might not be considered an error. It might actually be considered successful behavior for that API, depending on who's written it. Maybe they want that as part of their documentation. You want to consider what an erroring call means for your API. Additionally, it's not just the high-level errors. You might have errors you've written in yourself, and you'll be wanting to measure those as well. Errors are a little bit more complex in APIs than it is in services. But again, in combination with traffic, if your traffic's going up, and suddenly your error is going up as well, might be the traffic that's a problem. So we can use this to gain context of what's going on. Then we have latency. I couldn't come up with a good example to draw for this one. But it's the time between getting a request to your API and responding. Again, like when we were talking about duration with services, if that's slowing up and you don't have as much traffic as would be a problem, you've probably got a problem either with your API or a lower down service. So latency in combination with your traffic and your error can give you a great clue about what's going on. And then there's saturation. Not everybody can measure saturation in this case, because it requires load testing. And I'll explain why with this example. So for this particular example, your glass is your API, and the water is how much it's being hit. You keep hitting it and hitting it and hitting it until it can't cope with any more. Your glass is full. And this is where you're at 100% saturation. From then on, you know to what percentage you're saturated. So if you're, in this case, I would be 30% saturated. Normally, my API would be OK. My other half's laughing at me. He's mean. But again, in combination, you know that your API might not be capable. It might be getting to that 80%, and suddenly everything else is throwing errors, and you've got problems. You know where your problems lie. Saturation isn't something I'm going to concentrate on today, because not only is it not always the easiest thing to measure for a lot of companies, it costs quite a bit of money to do load testing in particular for some cases, but also it's horrible to demo, and I can guarantee it will go wrong. So I won't be demonstrating this today. And this takes me to my second category of baseline for API, RED. RED was proposed by Tom Wilkie a while ago. He's done a few talks on this. And he did it based on Brendan Gregg's USE, because this is an easy acronym, I guess, but he wanted something that applied to APIs. And I particularly like this because the words say what they mean. Rate. It's the same as traffic. How much is your API being hit within a certain amount of time? E, error. It doesn't do the ratio like Google does. I actually prefer Google's definition in this case. I find it a bit more useful. But he just talks about high-level errors and errors that you're throwing internally from within your API. And duration being the same as latency. Now, RED tends to be the one that I advocate for in my work, more so than the Google signals, because the words, as I see them, are quite easily understandable. I don't have to explain saturation for a start. But also, they're the most useful to me. As I say, I work with a lot of Lambda, and measuring saturation in that case wouldn't be the best idea. So there's a lot of overlap here. RED and the 4 golden signals have the same idea. And when a lot of people are having the same idea, it normally suggests it's probably a good one. Oh, we're not going to mention Brexit here. Sorry, British, had to make a Brexit joke. So with this in mind, I'd like to do a demonstration of what this actually looks like. I've got a little API I've written. I can actually show you. Because by little, I mean little. It's available on my GitHub. This is where we pray that my internet works properly. And, ooh. That's not where I want to go. Sorry, that's all we could do. So all it does is I send it an integer, and it will change that into a status code for me. The reason why this is so small is because all I needed was a timer. My timer, in this case, will also count how many times it's being hit. I'm using statsd, which is an open source telemetry tool that was originally written by Etsy. In this case, I'm using Just Eat's implementation of it, because I quite like their implementation, to be honest. And all that's going to happen is I'm going to send this some 200s and 500s, and it will send me back the corresponding status code, which you can see here. And it will also give me my duration with that timer. The other thing I'm using is a tool called CattyCoder. Has anyone heard of CattyCoder here? Ooh, OK. If there's anything you take from this one might be quite handy. So I don't work for them. I just really like them. CattyCoder is a training tool. So if you want to learn anything about Docker, for instance, it will host a little terminal. You can do some Docker commands, etc. And it will walk you through with some guides. So for this particular demonstration, I've written one of these courses. So if I put in Grafana, it's not very loved, really, is it? But we've got this demo of Grafana and Graphite monitoring. WordShaker is the handle I tend to use. And you just click on this, and it will welcome you into the demonstration. Lovely. So CattyCoder hosts my Docker instance in this case. I've got a tiny little machine here that the poor thing can't handle Docker. So in this case, it's a lot easier for me to use CattyCoder, not only because I can share this actual course with you, but also I can just run it in the browser, and I don't have to worry about my poor laptop dying. And within my Docker instance, I have a few images. So first of all, I've got my statsd server, which is listening for those telemetry calls. And I'm using Graphite in this case. So statsd will listen for those calls, send it on to Graphite. And Graphite consists of 3 different things. There's Carbon, which has my configuration for my aggregations within the Graphite stack. Whisper, which is my time event store. So this is particularly good for having time-based data. It will do my aggregates for me and sort them out over time. So it's quite quick to search through, but also quite space efficient. And then you've got Graphite, which is used for querying Whisper. It does have its own user interface as well. It's a bit feature limited in my personal view. So in terms of my user interface, I'm going to be using Grafana. The other reason why I'm using Grafana is because I use it at my current work and actually in my past workplaces, because it can take numerous sources of data, which means you can have all your graphs in one place. But we'll go into that a little bit further. So let's try to do a demo. And hopefully, I've made the right sacrifices to the demo gods, and this will all go well. Right. So we'll come to CattyCoder. The first thing I'm doing, you can click on the commands to do things, is this Docker network create monitoring. This is creating the network in which all of my Docker images are going to communicate across, and it's named monitoring in this case. The next thing will take a little bit of time. Is this Docker run, et cetera, et cetera. So the -d means it's a detached process. It will all break down once I close down my CattyCoder, which is why I want that. I've given it the name of Graphite, so it's easy to interact with within my terminal. And then the following lot is a list of ports that I need opened. The one that I want to point out is this one here, the 8125, because it's got UDP at the end. That's my statsd. That's my port for my statsd. It's recommended that you use UDP, and in order to use UDP rather than TCP in Docker, that's all you have to do, is just a /UDP at the end, because I don't want to lose my packets. I'm telling it that it's on that network of monitoring that I've just set up, and then the final bit is the image that I want it to pull down. Now, this demonstration, before I continue too far, I'll let it pull down the next bit because, unfortunately, Grafana can be quite large. This isn't what I would do in production, but I will talk through how I would alter it. It's great for proof of concepts and demos, though. But in the background, if I can remember where this is. No. I apologize, my mind's gone completely blank. I do a pull on the load of CattyCoder of the 3 different images that I use. It's literally docker pull Graphite, docker pull Grafana, /Grafana. So with those image names. Apologies. So the next thing I do is to pull down Grafana. This is my UI that I'm using. Again, running it as a detached process, giving it the name of Grafana so it's easy to interact with. I'm opening the port 3000, and that's going to be the port which I access it with. And telling it it's on that network of monitoring again, and what is the image that I'm referring to. That's actually pulled down quite quickly, which is lovely. So on CattyCoder, we have this display 3000, handy little tab, which, drumroll, loads of Grafana. Fantastic. So if I just quickly log into here, it's just a default for this, so it's admin, admin. Could not be easier. Right. Now we have Grafana. What I will do is, if you go down to preferences in your account, you can change the theme. I normally prefer dark, but this might be a bit clearer. OK, so what we've got in Grafana is we can add a data source. As I mentioned, I like Grafana because you can use it for multiple different tools. So in the case of my current workplace, I say current workplace, I actually just left them last week. I'm going to a new workplace now. But we use Graphite and CloudWatch and Elasticsearch but had all of our graphs in one place. The reason that this was useful is because all the teams knew how to use the same UI, which meant we could all actually talk about each other's graphs relatively easy and access them and understand them. In this case, we will be using Graphite. So it has the default name, which actually suits me quite fine. Graphite's a fine name for this. You tell it where it will be accessing data from. And then there's a few other options on here. So you can say whether it's server or browser. You've got your whitelisted cookies. Various auth options. I haven't had to use a lot of them. And I'm yet to find out why you'd want to use skip TLS. If you do find a use case, I'm still looking for one. And the version of Graphite that you might want to use. In this case, I know it's 0.9. So you can save and test, and it can find that data source. Super. But it doesn't have any data yet. So my little response API, which I talked about earlier, is available on Docker Hub. Again, all you need to do is search for WordShaker, which is my handle, and it's the only thing I've got on there. So easy enough to find, and if you feel like you want to tweak with this later on, feel free and have a play. Oh, so there's another thing with CattyCoder. This came in last week. I can change this to light theme as well. Sorry, I did forget at the beginning. So if I go to CattyCoder, I've got my response API. Same thing as you've seen before. I've given it a name that I can interact with it with. I've put it onto port 5000 in this case. It's on the network of monitoring. And there's that image that you just saw in Docker Hub with WordShaker 90 response API. That's pulled down nicely. Now, if I was smart and didn't have this on CattyCoder, I would have probably scripted this next bit. So unfortunately, you'll have to bear with me, because I've got some curl commands here. And all it's doing is it's sending a post to my API, giving it either a 200 or a 500, so I can get my HTTP codes back with the corresponding ones. So I'm just going to hit this for a little bit. I do apologize. And hopefully, the results will look semi-decent. I've got an example of what these particular baselines look in production as well. So we shall see. But this just gives me some data so I can make a graph with. And just to, oh, sorry.
Did you check what happens when we send strings?
I haven't actually. I mean, it is written to take a string and encode it, so it's fine. But and you can see that it's working here as well, which is useful. I haven't actually. I should probably change it so it just takes the integer. There's a couple of things I'd like to tweak, to be honest, in this API. I haven't got around to yet. Well, hopefully that will be enough. Cool. So on this actual course, I go through what I've just talked about in a bit more detail as well. But let's try and make a graph. So if I go up here, I've got my create dashboard. And we want to choose a visualization. This is the most recent version of Grafana. I did this talk a couple of weeks ago, and they updated it the day before. So it was quite interesting when I had to demo it. But I've got to admit, it's got some really nice features. So now, with Grafana, it takes you instantly to the visualization page. And you have some defaults that you can use across all the graphs that you're making from here. For this case, the one that I want is null value, but I'll show you why. So if I go to my queries, how clear is that? Oh, it's actually quite clear. That's good. So I can go to Graphite, which is the data source that I set up earlier. In this case, it is actually set to default as well, because I've only got one data source. Is that big enough to see from the furthest at the back? Great. That means I don't have to zoom. So I go to select metric. I want stats, timers, because I only have that one timer. I tell it which API I want, which is my response API. And I'm going to start with rate. So I could do 200, could also do 2-star. It does take wildcards within graphite. Oh, code, sorry. Thank you. Code. Need to tell it what it's actually looking at. And then I can do my 2-star to wildcard it. So I'm going to start off with rate and error. In this case, I want my count, because it's a distinct number. Now, in old Grafana, I'd want to do a transform null. I will explain this now. So I'll just zoom in. You can either zoom in using what I just did very incorrectly there, a kind of click and hold, or you've got your time at the top. I'll do last 15 minutes, just to make sure this stays here. So normally, I would do a transform null. Because of this big gap here, I can change that to have null as 0, which is now an option in your visualizations. Just means if I'm not getting anything through, it'll still have a line there. Makes it a bit clearer for me. I'll go back. The next thing I want to do is a sum series. Because we're getting lots of individual counts through, lots of individual hits, this will aggregate them into a sensible number. And the last thing is, I will zoom in for this. Grafana doesn't have the most sensible names for its legends from the start. So you have this sum series stats timers response. And as I mentioned, part of the reason for having these baselines is that anyone can understand your graphs. This does not help. So what we do is there is the option to alias, which is just to give it a name. And in this case, I want this as my 200 rate. Now, to speed this up a bit, we do have the option to duplicate queries with this little copy sign. So I'm going to quickly add in my 500s as well. There's my errors, and there's my 500. Right. So we have our success and errors, but it's not very clear. So what I want to do is add some series overrides. If I go to the visualization tab again, I can go 200 rate. And in this case, if I add bars and lines, I want to remove the lines to make this a little bit clearer. I tend to use bars for distinct values, such as counts, and lines more for continuous measures, such as time. And though I like the green for my successful calls, I don't like the yellow for my error. I think error should always be red, personally, because it makes me look at it. So I go to color change and red. There's numerous ways of doing these things on Grafana. You can also click on the legends, and there's options there as well. Let's quickly have a look at this. So as I mentioned, Google like to do their ratios. And this is why I quite like doing it this way in Grafana. I've got my count. I can see on the side how many times it's being hit in total. What I've also got is when my error overtakes my successful calls. As soon as that bar goes red, I know I've got a problem. Some people prefer to stack their bars, so you look a bit more like this, and you can see the full number of calls. Personally, my error rate for a lot of the things I work with is much more of a concern to me. As soon as my graph turns red, I know I've got an issue, and so does the rest of the team. So here we have our rate, and we have our ratio of error to success. The next thing that we want is our duration to get a complete RED. So I'll add a couple more queries. This time, we want to use that timer. So again, we want stats, timer. Ooh. I should have just copied this, sorry. Response API, code. We'll do the successful ones first again. And instead of count, I want mean, so I can get the averages through of my times. This time, I want an average series, which will aggregate those times again, and give it an alias. So we want 200 duration, if I can spell. There we go. So to zoom this a little bit faster, I will quickly add in my 500, if it'll let me click on it, and change my alias. Now, this looks quite confusing at the moment, because we've got a lot of bars going on, and it's all on one axis. So I'll go back to my visualization and add a couple more overrides. First thing I want to do is to take away those bars, because I've got continuous time here, so I would prefer a line. I'll make these a bit wider so you can see. There we go. And what I tend to do is make the colors match. So successful, always green, errors, always red. So I can tell what's referring to what. And I'll do the same for this one. The other thing that I would suggest is to use the other axes. So whereas we've got count on your left-hand side here, we can actually use the right axis as well, with y-axis too, and that will pop my duration onto the other side to make it a lot easier to actually read. So I'll do that as well. So that's both of my durations over on that side. I can pop them over on the graph using this as well. So that's just clicking onto the legend, y-axis, use right axis, and it'll pop it over to the side that it's referring to. Couple of things. When you've got two axes, I like to align them so that they start at the same point. I tend to start mine at 0, because 0 calls is a bad thing in a lot of the APIs I use. The other things that you can do is change the units. So in this case, I might want milliseconds for the thing that's referring to time. You can add labels if you want to make it clearer still. So in this case, I've got my duration and my rate. There's a lot of options now with Grafana, which is great. So you can show things as tables. If you're using USE later on, you can also show your minimum and maximum values as part of your legend. So if I do have the time of my oldest message, I can show that quite nicely. There's numerous things that you can do, which is very nice. The other thing that a lot of people ask about is you can also configure alarms with Grafana. So if you do have a threshold that you're looking for, you can set an alarm for when it goes over it. Personally, I like to use PagerDuty. But that's a discussion for questions if you have any later. So right now, we have our rate, our error, and duration all on one graph. And I'll just pop it onto the actual dashboard. And this is what you would have. In the teams that I've worked in, we'd be responsible for domains, as a lot of people are. So we would have our rate, our error, and duration, seeing how they're corresponding to each other, knowing how to react when that API is reacting in a certain way. But we'd also have our USE, or in my case, DSE, duration, saturation error, for the services below that API, next to it on the same dashboard. That way I can tell if it's my API that's misbehaving, or whether it's something further down that's causing my issues. But either way, it means that I can look at one screen and tell what in my domain is acting a bit funky and needs a bit of love, and what is acting OK. And the best bit of this is that in the company I just worked for, it meant I could go to any team and know what was happening with their particular services. So I didn't have to ask them. The worst bit of this is we trained our product manager how to read them. So we would be coding, like getting deep into it, not really knowing what's going on around us, not really paying attention to our screen. And he'd pop by going, "That's not supposed to be read." And all of us would scramble to suddenly fix it. I don't know whether I recommend doing that or not. It gets you in a little bit of trouble occasionally. But it is also nice having the extra pair of eyes. It's also occasionally nice doing it to other teams. But I don't advocate for that. So that's a simple demo of how you can show the basic stats you need to know how your API is working. And the same thing works for services, as I mentioned. As I said, that particular example, CattyCoder, isn't really for production. You can play about with it a bit more, put the same commands into a Docker Compose or Dockerfile or otherwise. But I particularly like CattyCoder because It's easy to go away and have a play with. Everything that I've shown you is open source as well, so if you want to adjust it, feel free. It probably needs a bit of adjusting, if I'm honest, but it's good for a demo. So what about production? I do work with AWS, have done it in my most recent company and the one I'm going to. But what you've just seen is very similar to the same setup as the company I've just departed from. So we have ECS, our Elastic Container Service, which has exactly the same images for Graphite and Grafana that I just showed you. In fact, they have updated Grafana as well, so it is exactly the same images and the same versions. Slight difference is with ECS, there's a few things that you can set up with Grafana. So you've got the port mappings, same as I showed you with the command, but you can actually use that as environment variables, almost. You actually have your environment variables. You need to be specific about where your config is, so it has an endpoint for the config for Grafana, and it has your address for Graphite as well. This is the big thing that surprisingly comes up a lot. Keep your config outside of Docker, please. And also keep your data outside Docker, please, because as soon as those containers go down, you've lost everything. It's surprising how many people have done this. So in the case of Uni Days, where I did work, we had a bit of an interesting setup, in all honesty. So we had our statsd config for those aggregations of our telemetry within EFS, and our data for Whisper in there as well. Strangely, we had our config for Grafana and Postgres. This was a decision made way before I joined, and I still haven't been able to find out why. If you are using, does anyone use AWS here? Cool. If you are using AWS or choose to in the future, just use S3 for your config files. It's a lot cheaper. There's no reason to put it in Postgres, but never mind. The most important thing is to keep it outside your containers. And what I want to emphasize here is that it's not much of a different setup. We had a compose file, and that was about it. And because of this, we also had an endpoint for our CloudWatch and our Elasticsearch. We all had the same UI, we all had the same setup, and we all had the same baselines. Which also made it easier when you're working with the operations team who are also using USC. Little side note, CloudWatch uses USC as a standard for its infrastructure, which is great. So you actually have the utilization saturation error built in. Unfortunately, I haven't checked this week, but before you haven't been able to alias with CloudWatch metrics, so you just get the massive legends, which is a bit of a problem. But do these metrics help you in real life? Well, if it didn't, I probably wouldn't be here. I would be telling a different story and just crying in front of you all. But they do. This is a semi-anonymized, blurred-out graph from my old workplace. As I mentioned, we used a lot of lambdas. And we had a little bit of an issue. And it's not surprisingly, oh, sorry. Oh, sorry, I thought somebody was asking something. It's not surprisingly the 78 errors. Unfortunately, that was semi-normal. It was actually the big red bars down the bottom here. That was not expected. And we had a little bit of a heart attack about that, in all honesty, because we couldn't see any problem with the actual lambda. So we went to the next stage. And in this case, we had kinesis underlying. And there's this big purple spike that goes up to 42 minutes was our iterator age. That was the biggest problem. And it was because of the way that this particular lambda was constructed. We had a bad construction that basically cached, trying to put it as simply as possible. But we found this within under 5 minutes, because we spotted the red bars and instantly went to the services underlying it, because we couldn't spot a problem with the API. And also we had rotating dashboards, which has all this stuff on. Even better, our infrastructure team had access to the same dashboards, and they helped us give it a bit of a kick. Not the best way to solve the problem, but we also solved it with code afterwards. Just to give it a bit of a sticky plaster, they restarted the whole thing for us, in all honesty, and it got rid of our problem. Also very good because it meant that our customers were happy. We dealt with it in a time that they didn't notice anything had gone wrong. This is particularly good for front-end metrics as well. We did have a front-end team, and as soon as they saw any increase in loading time on the page, they were on it like Sonic and found out which of us lot in the back-end team had messed up their interactions, because it was normally us, not them. But they also had access to that information, so they knew who to nag in their case. It was normally our team. So I've gone very quickly through why I believe baselines for dashboards are important, why I think dashboards are important, and a few different tricks on what to use. But where can you learn more about this fascinating topic? All the slides and resources from this talk are available on my notice page. Link is there. I will also share all of the resources on Twitter. This includes all the references I've done for research for this piece. Tom Wilkie, I mentioned, he's great. He came up with the RED method. He's done quite an in-depth talk around it at GrafanaCon last year. And Brendan Gregg, I've got the links to the USE method in there, but actually I highly recommend a lot of his articles. Very smart dude. You've got the Google SRE book. If you don't want to buy it, it's available online for free. Really great reading. Occasionally I blog when I actually get around to it. I will be writing up this one quite soon. Practical Monitoring by Mike Julian is a fantastic book. It's very light, goes through different types of monitoring, from security monitoring to front-end monitoring to back-end monitoring, whatever you like. But it gives use cases of different companies using it and how you shouldn't do it exactly the way they do it, because it's not necessarily the right way for you, but the points to take home that are important. Highly recommend that as a starter for 10. But the place I learn most is conferences like these and just talking to people. When I first started getting into this topic, wasn't that long ago, to be honest, it's because I was working in a place that didn't really use monitoring in the best way. And I wanted to learn about logging, dashboarding, alerting, all the aspects of it. So I took to Twitter and went, who can help me with this? And it resulted in me going to visit local companies, seeing what they had done, and learning about what they really wished they hadn't done. And if I hadn't gone to see them, I'd probably be bald or gray by now. Because it turns out when you learn these things in production, people get angry, and it costs them a lot of money. Had a little bit of a mistake once. But through talking to people, you learn about the fascinating problems they come across, their companies. You can trade war stories, and to be honest, you're coming to events like this, so you've already made the first step. You're surrounded by smart people working on interesting problems. You can learn from them. And on that note, please talk to me, because I can learn from all of you. And when you go to these events, I just like to throw this in, because it's something very close to my heart as someone who comes to a lot of these events by myself. Please use the Pac-Man rule. Lots of people stand in tight circles. If you leave a gap, some poor loner like me can come in and learn from you. So please leave a gap for the lonely people like me who just want to talk about dashboards and nobody likes to talk about graphs with them. We appreciate it. Thank you for listening. I will be around for questions. I would ask that you come up here, though, because I've had a bit of a sinus infection and my hearing's not that great. I've really been quite run down today. But I will hang around for questions. I hope that you found something useful in today, and I encourage you all to go off and make lots of great graphs. Thank you very much.